Let's write 1 over 3 to the 5 as a power with a base of 3. Well, what we learned earlier was that if we take the reciprocal of the base, we change the sign of the exponent. So 1 over 3 to the positive 5 is equal to 3 to the negative 5. Let's try question B. Let's write 8 to the negative 4 as a power with a base of 1/8. Well, 1/8 is the reciprocal of the base in this power. So if we're going to take the reciprocal of the base, we should change the sign of the exponent. So 8 to the negative 4 will be 1/8 to the positive 4. In other words, when we take the reciprocal of the base, we change the sign from positive to negative or vice versa. We take the reciprocal of the base, so we had to change the sign of the exponent. Okay. The next question asks us to evaluate each of the following and to express our answer as a whole number or a fraction. In other words, we don't want to see any decimals here because that would show that it didn't really take thinking, you just knew how to use your calculator. So let's figure out what 7 to the 3 equals and what 7 to the negative 3 equals. Well, 7 to the 3 is equal to 7 times 7 times 7, which is 343. 7 to the negative 3 equals 1 over 7 to the positive 3, which is 1 over 343. Pretty straightforward application of our negative exponent rule. Next question. 1 over 5 quantity to the exponent negative 2. In order to figure that out, what we do is we take the reciprocal of the base, so 1 over 5 becomes 5, and the exponent of negative 2 becomes 2. 5 to the 2 is simply equal to 5 times 5, which is 25. For our next example, what does 4 to the 0 equal? Well, this is a quick one. 4 to the 0 equals 1, because if you remember, any base raised to the exponent 0 equals 1, with the exception of 0. 0 to the 0 is technically undefined, but we won't worry about that right now. Negative 3 quantity raised to the exponent negative 5 is going to equal 1 over negative 3 to the exponent positive 5. Now we don't change the sign of the base, we just take the reciprocal of the base, but we change the sign of the exponent. Okay? So we get 1 over negative 3 times negative 3 times negative 3 times negative 3 times negative 3, which is 1 over negative 243. I personally prefer to put the negative sign in the numerator, so it's negative 1 over 243. Our next example, 1/4 to the negative 5 times 1/4 to the exponent 4. Well, 1/4 to the negative 5 times 1/4 to the exponent 4, since we have like bases, we use the product rule and we just add the exponents. Negative 5 plus 4 is negative 1. So we have 1/4 quantity to the exponent negative 1. Well, in order to evaluate that, we simply have to take the reciprocal of the base and change the sign of the exponent. So it becomes 4 to the exponent 1, which is, of course, 4. And our last example here that we'll do together, we have 2 to the exponent 3, quantity raised to the exponent 2. Well, this is an example of the product rule. We multiply the exponents, and we get 2 to the exponent 6, which becomes 1 over 2 to the exponent, 2 to the exponent negative 6, which becomes 1 over 2 to the exponent positive 6, which becomes 1 over 2 times 2 times 2 times 2 times 2 times 2, which is 1 over 64. No decimals needed. Isn't that empowering?